Hey guys, welcome back to the Cloud Chat. And after an interesting discussion last week about AWS reference architectures, today we'll be digging into part two of the same topic. And today we'll be talking more about image recognition and some other interesting stuff that AWS has on their reference architectures. Shamat?
Yeah, Damon. So I think last week we did like a quick version on the web and the mobile backends, which can be done with Lambda architectures. So this week we'll focus on their image processing and that sort of like image level things they have mentioned in their Lambda reference architecture. So let me share. All right. Okay. So in their official Lambda reference architecture page, we have three different architectures which they have defined. I think we'll start off with the basic version, which is the image handler. So let's go into that and see what it means and what it has. All right. Okay. Let me accept. Okay. So this architecture is actually implemented. So as we can see here, so it's using obviously using Lambda, and then so it says the aim of this architecture is to create like different versions of the image. Let's say we upload the image, use uploads the profile picture image, and we want to create like multiple versions of that image for mobile, for web, different versions. So that sort of use case are like very common. I think as you can like even Damien, you can give some thoughts on that. So it's very common that scenario.
Correct.
Like some people might, yeah.
Correct.
So
So for
for example,
example,
yeah,
like if you take Facebook, the little profile picture you see on the top might be something like 240 pixels by 240 pixels. That can be one version. When you click on it, it'll open up another full HD version. When you download it, maybe it'll come as another version. So versioning
yeah.
is pretty important because images are some of the largest objects that reside on a web page. So trying to minimize it and trying to reduce its footprint is quite important.
Yeah, yes, Damon. So yeah, so let's get into the architecture and see how AWS proposes we can do this uh, do the processing of these images in a serverless manner, and we're using AWS Lambda. Let's see. Okay, so we have the client in the front, and okay, everything starts with Amazon Cloud Front delivery CDN, and then we have the API gateway which talks between the application layer. So I assume, let's assume a scenario like this. I upload my profile picture, let's say to the cloud chat YouTube channel. So I'll upload my, let's say 1 MB file there. And as soon as it hits the API gateway, it will have like a use upload route. And that route will call a Lambda. And so that Lambda can have the storing part. Okay, this is the key of this image. So I have already stored into the S3 bucket, which is the original file. And that's already having the key. And then the same Lambda or even different Lambda, so we can use it as like step functions, like multiple steps even. So for example, we'll in this scenario we'll just assume everything happens in the same Lambda. So in that Lambda itself, what they can do is, so they can basically create multiple versions. Let's say using, if they're using Node.js, there's a library called Sharp, which is a really good library to do this sort of image processing stuff. So you can install Sharp library here in the Lambda and like basically create multiple versions. So I'll create 200 by 200 pixel image, then crop it and even put a watermark on it. Even like you can do different manipulations in this sort of scenario. So it's basically pretty simple. So we came into the Lambda, we create a version of that image. Maybe it's creating in base 64, and we converted it and like store into a physical file in a S3 bucket. And similarly, I think step number 5 is to get the keys, secret keys, I guess, to access S3 bucket and other related access to the other services. So then we can see after step 4, there's a step 5, then there's step 6. So I think as I read in the below description, it's for like other analysis, like let's say not metadata, let's say that image, we want to like moderate that image. Let's say if I'm uploading a very bad image, let's say if it's
PG-18.
a what do you call, yeah,
PG-18.
PG-18. Simply said that. So yeah, so we can use Amazon recognition service to do that sort of stuff and just get like even object identification, do any sort of like good recognition stuff directly pre-built on Amazon. Yeah, so that's pretty simple. And then the other way around, so you can deliver the image onto the other side of the platform. So the viewer from the other side, so us as YouTube, like let's say our profile picture will be uploaded instantly, and we'll only see the 200 by 200 version, and we might never see the real image someday. Yeah, so Damien, hope I made it like very like quickly. I went through this process because this is like the simplest image processing architecture they have proposed in their architecture references. So Damien, any thoughts? Did I miss anything? All good up to now?
No, all good, yes. So, basically, what I feel here is the only image recognition part comes from Amazon recognition, right? It's not basically from
Yeah.
the Lambda.
No, it's a third party. So so they have said here like you can use smart crop or content moderation features from recognition. So you can use like if you want to do that sort of things you can do. If not, you can just forget about it and uh, just ignore that. Oh yeah, so they have said here, they mean the URL signature feature. So I think that's why they are using secrets manager to validate the signature of that image URL. I think that is also optional. Like I think 5 and 6 are actually optional if you are implementing a basic image processing sort of image handler using Lambda. So you can ignore the last two and even focus on the top 4
Yeah, so this is the
points.
first
Yeah.
time I'm hearing about image URL signature feature. I haven't heard of that
Yeah, I
before.
think I I guess it might be to do some what do you call
Some sort of hash validations or something like that, right?
hash validation and sort of like block access to this sort of
Yeah.
user levels. I'm also not sure why they're using, but there's this S3 pre-signed URLs and things like that. If you want to use similar functionality, like you can time out the image access time and things like that.
Correct.
Yeah, maybe that's using that. Let's assume that. Uh, but what I'm actually interested in the like the core like the main process like 1, 2, 3, 4. So that's my key. I think
So,
the idea I want to share.
the way I have used this is in a different way. It's not exactly this. So, what I have seen is you have CloudFront obviously, but behind CloudFront you have your S3 bucket, and behind the S3 bucket you have AWS Lambda. So, what I have used this for is actually this was also based on serverless. When a person uploads his or her profile picture, it goes into a queue, and then using some sort of serverless Lambda functions, we process the image, we create different versions of it, and we store it in S3. And then that is directly accessible through CloudFront. So there is
Yeah,
basically no
that's
processing.
there's no like wait like a synchronous
Exactly.
yeah. So yeah, I think this is just to explain the very high level. I think the simplest way to do that, like let's say we just want one version of that image, maybe this might be quicker, or if
Correct.
the
Yes.
user wants to see that image itself there, like like you have preview windows and so yeah, that's true
So,
actually.
here
Using
what's weird is that you have CloudFront, and behind CloudFront you have API Gateway and AWS Lambda. So what I'm assuming is CloudFront might be communicating with the Lambda once the cache expires, and it sort of behaves as a cache for the request, right?
no, I think it's to serve the image outside. So if you want to serve the image in a like a very distributed manner, you need the CDN. Let's say I'm using the UK internet and you're using a different internet, and like distributed nature comes with CloudFront. So if you want to deliver fast, I think you can.
But I don't think CloudFront will always be communicating via API Gateway to Lambda, right? They will be caching
Not
the
yeah
stuff here.
yeah yeah they will cache in the request. Yeah,
Yeah.
yes, that's correct.
Otherwise, it won't
So
make sense to use CloudFront there.
yeah, so provides the caching layer to reduce the cost of image processing and the latency. Um, yeah. Oh, I think let me. Yeah, I think this is like for dynamic image manipulation, Damien. So as they have mentioned, so
It's
yeah,
not
this
for
is
static images.
not for static image. So you do it and then you get a
Yeah.
image at that point. So you basically need to call the endpoint and then it will cache it for some time and it will just trigger again. Yeah. So this might be a different use case which we might not use in our day-to-day
Correct.
like
Yes.
development stuff. Yeah. As I remembered, I think I've used this. Sharp for Node.js early. I think I just found the repo. So you guys even can have a look, and we'll share these links in our description. So this was like a very quick version, which basically does some like three versions. So original, large, and small. So it will store into these three folders, basically a single image when it's uploaded. So I think this is using Sharp. So yeah, this is just like a hobby project. I think it's 3 years old. So you guys can just have a look if you want to like explore this Sharp a bit in detail.
Nice.
Um,
So
yes.
is that also based on serverless?
No, I didn't do it on serverless, but this is just like a
It's
Node.js
a
single,
Node.js.
like a
Okay.
simple function. Yeah, yeah. I think you can just use it on a Lambda function because this
Mm-hmm.
uses S3 to save the image again.
Mm-hmm. Got it.
Yeah. So that's our first architecture for the day. So that's the first image architecture we are talking about here with AWS Lambda. Uh, so do you want to talk a bit here, or we go to the other two and maybe come back to this and compare a bit? What do you
Yes, I
think?
think I think let's go to all of them and then come back for a roundup.
All right, perfect. Okay, so the next one, let's go into uh, image recognition and processing. So yeah, let's go into that. So it's on their GitHub, AWS Lambda reference architectures. All right. Yeah. Okay. So this is a bit of advanced architecture than the one we just saw a while
Mm-hmm.
back. All right. Okay. So let's go from the front again. So there's a client application and it's using AWS Amplify. So it's a web application here, as they have mentioned, browser. Then it uses Cognito for the user authentication, and there's AppSync GraphQL layer, and then there's S3 bucket for the photo upload and download function, and then there's a Lambda which handles that workflow. So I think it triggers the Lambda as soon as the image hits the S3 bucket, it will hit the start workflow Lambda, and then it will go into the other step functions in the middle here, and then it will have all these 4 different Lambda functions again. And one is to extract metadata, one is to do object and scene detection, the next is to generate thumbnail, next is to do the persist extracted metadata into a DynamoDB data store. All right, this is interesting. I mean, at this stage itself, because
I
it
think
uses
I
many.
think this is what I think this is what Facebook does.
All right.
They extract
So
metadata. They do objects
yeah,
in
they do the
detection.
tagging.
They
Yeah,
tag it. They do everything here.
yeah, they recognize faces. They do every sort of thing possible, I guess,
Correct.
using
Yes.
the. All right, so let's go in slowly. Okay, so I think up to now, our viewers should be clear with these two functions. At like it's a bit common scenario using AWS Amplify to do all these things together. So it's much easier to do this and configure things here. Okay, so there's a Lambda, sorry, GraphQL resolver here, and it I think connects to DynamoDB and again connects to step functions. All right, okay. So so as soon as a photo or image is uploaded, so the S3 bucket outside here, so the meaning of that, as I see here, is basically it's connected through AWS Amplify. That's why it's outside. So AWS Amplify library, you can call it like, let's say S3.put, something like that. So you can put directly from your client application. So that's why it's outside the, not inside the backend part. So it's here, then it will trigger as soon as a new object hits the S3 bucket, it will trigger that start workflow function, and then it will trigger the app sync. Okay. All right.
Um,
So then
does it need to actually trigger AppSync, or can't it directly trigger the step function?
I think it just needs to store, maybe to store the, let's say this image was uploaded or something
Uh-huh.
like that. Just like the persistence needs to be there, no?
Okay.
I think just to store the value, maybe. Yeah, if not, you can just trigger the step function. But I think you need the workflow, like this middle Lambda is actually required to trigger either
Yeah.
this or
Yeah.
yeah. All right. So we have the step functions in the image processing backend here. So this is where it gets interesting. So basically what step function can do is like trigger in like a very flow manner. Like let's say you can create like a proper flow. Okay, first trigger this Lambda, then trigger this one, then trigger this Lambda with the response of that Lambda. So you can do a very nice flow with step functions. So the first Lambda function they have added here is
So,
extracting the
so
metadata.
Chaman, before you go deep into that, like, what is the why would you use a step function? Why can't you have all of these inside one function?
Yeah, so one is basically to remove that waitingness. Like let's say you had to wait till the first method finishes, let's say extracting metadata. So you have to finish and keep on waiting till that part finishes. So it's one way to optimize the cost, and the other way is to simplify the flow. Like, let's say if it fails, where it fails actually, and you don't have like up a full instance of this Lambda to just wait. Like it's a wastage of basically compute power, I'd say, because we are using Lambda architecture here, and the ideal scenario is just to use it only when it's needed. So it will only have that uptime, like maybe like 3-second uptime maximum, more like even 1 second for smaller functions.
That's true.
So yeah,
I think another reason is that, again, we call this Lambda function. So a function is sort of a logical scoped amount of work, right? So all of
yeah,
these step functions are doing a different set of scoped work here. You extract
yeah,
metadata, you do a separate thing there, you do object scene detection, it's a completely different thing. You generate thumbnails, a different thing. So I guess it makes sense to have these in separate Lambda functions. And instead of, having one Lambda function trigger another Lambda function when it's done, and that going
yeah,
and triggering
exactly.
another one, it's all grouped together as step functions.
Yeah, exactly. So yeah, so the first Lambda function does metadata extraction. So I think they have mentioned here what sort of data they are trying to get out. Okay, let's say EXIF data, maybe the camera information, the focal length, and all the required information if they need, and the size of the image format. So things like that they can extract directly from the original image file. And okay, so they have mentioned a step here. Based on output from the previous step, validate if the file uploaded is in PNG or JPG. Okay, that's a very nice use case here. So they do a validation first. So you don't actually need to go to any of these other methods if it's not either JPG or PNG. So they have like done a quick validation there, and they will return a not supported image exception out. So that's nice. Then the next step is basically store the extracted metadata, right? Yeah. So they will persist the extracted metadata here, and then directly, so they have shown directly store it to DynamoDB, not go through the AppSync again and sort of the GraphQL layer. They'll just store it into DynamoDB. Okay, then there's other two. Okay, in parallel, kick off two processes simultaneous. Okay, so this is also another use case, Damien, which is interesting, which we can use step functions. So you can parallelly run two together. So the flow would go simultaneously. So one would call recognition to detect objects in the image file if detected show the stacks in image metadata folder, DynamoDB table. Then the next is to generate thumbnail and store it under private use ID and the resized image folder. Okay, so that's interesting. So they'll first do these two Lambda functions as a step manner. So they'll first try to extract. If it's not a support image format, they will basically throw error. If it's okay, they'll save the image metadata. So as soon as both are passed, only these two run in parallel. So I think that's what we can get from there, the walkthrough of the architecture part.
So I have a question here, Chamat. What would happen if an execution limit is reached? So this is a worst case scenario, but if an execution limit is reached, would these step functions behave in the same way, or would these be queued basically?
I think it would stop from that point. So it won't trigger the other function because you need that output data from the previous function to call the next one. So that sort of thing. But I think the limitations, they mean these would do it like very minor tasks. So I hope it won't reach that limit, hopefully. But let's say if someone uploads just like 100 MB file or something like that, you just need to load it in the Lambda. So we have to do front-end validation for that. Like as developers and engineers, we have to limit our user inputs. So that's the very dangerous part. Yeah, that's a good question actually. Yeah, otherwise if you don't limit the user, they'll try to do anything like okay.
Exactly.
So what they'll do next is do the object scene detection parallelly with generate image. So why they can do this parallelly is they are totally independent. So one is independent from the other, so it won't hurt generating the thumbnail while recognizing the images there. So that's why they are doing it in parallel. All right. So the detection part would directly call the image recognition API. service, and then it would maybe return that information and then store that information again into the DynamoDB table. Then the generate image would, they have said, create another image, resize like a thumbnail, and store it into the S3 bucket. Yeah, so that's basically it, as I see. Yeah, hope it's that's the case. Yeah. Okay, so they have given a sample here. That's a very interesting one. So they have implemented the process, and here you can see the metadata, image size, geolocation, device, and detected labels. So this detected labels part comes from the recognition API output. So these are the recognized labels for this image. So that looks very accurate in this scenario.
Basically tags, right?
Yeah, it tags. Yeah. Okay. Now we have a proper how it works. So you
A
can
flow
see
diagram.
flow diagram. Yeah. So this, I think this is generated from our. You can do this sort of flow from their dash, like what do you call the console, and like push and like put things here and there and like create the flow properly. So okay, it will extract image metadata. If it's not supported, just end it. That's the end of the process. If it's supported, uh, so yeah, so I think extract image metadata. So here it will fail if it's like, let's say, a different file format. It would fail if it's a blank file. It would fail. Image type check is the next part of it. Maybe PNG and JPG validation here. Then they transform the metadata, and here again they do the recognition in parallel and parallel with thumbnail generation. Then they directly store both together. So as you can see, Damien, here they will flow the data from one to another. So here it would persist the metadata information from the above and keep it just for now like temporary, and then they'll again pass it back to this store image metadata with these two outputs together. Yeah, and this would just store the received output into the DynamoDB table, and that's the process end. Yeah, I think this architecture actually had more information, like it has a proper, okay, it's recently updated as well. I didn't see that. So yeah, this is a good repo. I think we can share with our audience. So
Correct,
I think
yes.
they have properly done with like screenshots, and otherwise it's sometimes you will feel like the code is not working and you don't know what it looks like. So this is a good example of a good repo which AWS has given to play around for you to like try out these functions, like features. Okay, yeah. So Damien, any thoughts about this? So we did like a full recap on like a full version on this. So any thoughts on this?
So personally, if I was implementing this in the industry, I wouldn't necessarily go for this approach, because again, it's like this. So if you have a large engineering organization, sooner or later, I have had this experience, sooner or later these limits will be reached. Either your EC2 limits or your Lambda limits or something will be reached. So my personal opinion is I prefer event driven stuff. So what I would do is, once the photo is uploaded onto S3, I would start a workflow. Or what I would do is, as and when the photo is uploaded onto S3, once the success comes from the backend, like from maybe although this is a browser, I wouldn't directly connect AWS to the browser. It would probably go through maybe a GraphQL API or a GraphQL gateway or some sort of BFF. So that's a backend for front end. And what I would do there is I would first confirm the S3 upload that it's successful, and then I would dispatch an event to an SQS queue, saying that, okay, we have something ready to be processed. We have an image that is ready to be processed. And this start workflow Lambda function would be basically listening to that, and it would say, okay, there's something ready to be processed, these are the stuff, and then it would dispatch it maybe into another queue for each of these separate other Lambda functions. So the reason why I say that it's better to always use a queue is so that you can set a limit to the number of Lambda functions that are listening to that queue. You can scale up, you can set a maximum limit, you can set a minimum limit, you can set a desired limit. So that's very important, especially when you consider all these account limits that we face. Also, having more and more Lambdas running also incurs a lot of cost. So image processing, this sort of image processing is not exactly, I wouldn't call it very it's not a critical user flow. So you can just upload it and just forget about it. All this stuff on the back end, where you extract metadata, you do recognition, you store the data. The user doesn't care about that part. So that even if it happens like maybe 15 or 20 minutes after he has uploaded it, he or she has uploaded it, it's completely fine because it's not user facing. So I would always have some sort of an event-driven approach in the middle of this, so as to reduce the costs, as well as to make sure that we don't breach any of those account limits anytime soon. Because I have experienced the fact where people say, okay, Lambda, okay, the execution limit is 1,500. We can create any amount of Lambdas we want. And as the organization grows and grows, as more serverless functions are introduced, you start to breach that limit. So then you have to go back, you have to refactor all of that code, you have to rethink all the architecture, and you have to come back.
All right. Yeah. So Devin, I think you might have like missed the point here. Like, so S3 is trigger. So there's a S3 trigger here added. So I think they have gone into like some sort of event driven, but not like the SQS, SES.
So
manner.
the thing with S3 triggering, what I don't like is S3 triggering this workflow. So say you have maybe 100 people at the same time. Say it's a brand new website. People sign up, they upload photos, and you have this architecture from the beginning, and you have about 100 people uploading photos every second. So what S3 will do is S3 will trigger 100 functions called start workflow every second and start to push it. So that is what.
All right. Yeah.
So that's something that I don't like. I mean, that'll be a huge cost, and it's out of our control because it's in the control of S3 and not in our control. So what I would prefer is having something in the. So this GraphQL API can actually sit before S3. And what this can do, instead of GraphQL, what would be much better is a BFF, because you can actually code it much more better. But even in GraphQL, you can customize this. And once the upload has gone successfully to S3, you get the metadata from S3, and you just dispatch another event to an SQS queue, which is listened to by start workflow, and he then decides, okay, is this something that we need to process? Is this something we don't need to process? And then he decides, okay, we need to extract metadata for this, we need to do that, this and that, and then he sends it out to the respective parties there. So the reason is, like, say you have, I mean, this is very common, say you have something like Twitter, or you have Clubhouse or something like that, and you just create it and you you launch it and say, okay, anybody can come and sign up. The first thing people do is they upload images, right? They upload their profile pictures.
Yeah.
And that is going to just bombard this entire architecture with a lot of requests.
I get what you're saying now. Yeah. So basically what you're saying is replace the S3 event trigger and make it more like a manageable sort of, like we need to control that. Yeah.
Correct. Yes.
That's a very good input. Yeah. I think, earlier I didn't get it that.
Because here, say 100 people per second upload images, you would start 100 workflows. But if you have a SQS in the middle, you can say, okay, I need a minimum of 3 workflows to always run, or this can scale up to this amount depending on the size of the queue. So you can set a limit and say, okay, only 10 workflows need to start per second or something like that. And that would actually reduce the cost a lot.
Yeah, that's a super great input you gave them in there. So I think that's why our channel is much more important, like critical, because we analyze from 2 different angles, and you would see one set of like with the different set of eyes, and I'd see in a completely different way. So for my area, let's say for research work or something like that, this would be very suitable. But I get what you're saying, like when scaling up, it would like create a whole chaos in this workflow, and sort of it would hit many limits in the end, like maybe the Lambda functions would time out, things like that happen. Then that's a super great input we got here. Yeah. All right. So I think we covered both pros and cons together, I guess. So we had the good sides of this and also the negative part of it. So yeah. All right. Overall, I think this is actually a good use case of Lambda once again, like AWS has presented itself. So this is why I think AWS keep creating the reference architectures for the users to like identify these sort of flows, like and even modify it a bit, like to our own taste and our own ways, and then deploy into the real world. Shall we go into the next use case, Damien? No, are you
Definitely,
good? All
yes.
good with this one?
All good with
I think
this.
yeah, this is yeah, we did this good in a good manner. All right, so let's go into the third reference architecture. So that's the last architecture they have here. So that's the image moderation chatbot. So let's see what it is. Okay, so as we saw the word chatbot, so it surely is a chatbot application. And earlier we talked about a web application and another like a server-side implementation. So let's see what this does. Okay, let's go in. Okay, here what they have. So let's start off. Not they made it.
Yes.
Okay, so in this architecture we can see there are users. So there's the chat client. So it can be a web chat client, and that chat client directly connects to API gateway. So that's the proper, like I mean, like normal API gateway, API request that will trigger a Lambda function, and then that Lambda function would do some like a API call or like a call to the image recognition service, and then that would go through back to the client again. So
I
I
think that
think
is
what they're trying,
WebSockets, right?
yeah, this one you mean?
No, from the Lambda
Uh,
to the back to the client. That looks like a
yes,
WebSocket
yes, yeah,
connection.
that looks like a WebSocket. Yeah, let's see. I think they should have. So they have done okay. A user post a message containing an image to a chat app channel that's monitored by the chatbot. Okay, so someone will post a message and an image. Sorry. So that chat app post to the API gateway. So we just discussed that. Then it would trigger a AWS Lambda function. It's all right. So that would download the image. So I think AWS Lambda would directly get the real image, let's say base 64 of that image, and then it would call the image recognition to check if the image is uh, having explicit content. So okay, so that's the use case. So someone would upload a image to a like a, let's say a public chat, and it needs to recognize if this image is good to be in the community or not. So that's a simple like a moderation tool they are trying to apply this into. So then chatbot uses the chat app API to post a message to the chat channel detailing deletion of the image. Okay, so if it's deleted, if it's not good enough for the to be in the channel, they will return back saying, okay, this image was deleted or something like that. I think Damien, this can be either like a response back to the chatbot or like a socket listening to that response. Yeah, so that's a very simple process. I think with the two other APIs, I think this is much more similar to the version one image handler, which we like discussed in the first place. So this is like the one of the easiest, I think, easy flows again. So not like the second image, what do you call that, reference architecture we discussed a little
Mm-hmm.
while back. So yeah, any high level thoughts at the beginning of this, at the start?
So to start off, just a disclaimer: I have never worked with chatbots before, so
Okay.
I don't know exactly how they work or anything like that. But it looks pretty
I think
straightforward.
this,
Yeah.
yeah. So this is basically a image moderation chatbot. So
Mm-hmm.
it is just plugged into, let's say, a forum or something. So
Correct.
someone puts
Yes.
something into a forum and it would trigger this back again.
Maybe something on
Um,
Discord or Slack or something like that.
yeah. So I think the use case is pretty straightforward, like not complicated at all. Like there's no like event triggering or anything like that. Just one to one, like directly go in and get the job done. So that's it.
Mm-hmm.
So yeah. So let's see. Let's go through their walkthrough. I think this also have like some sort of the description in their README, but I think the second one, which we discussed, had a very good overall repository like in that reference architecture. So yeah,
Mm-hmm.
let's see. Again, a user post the image with the. I think this is the same one as the above one we just went through. Yeah. Okay. So that's it. So I think they have implemented this here on Slack. So this is a integration for Slack channel. So when someone uploads a image to a Slack channel, it would do that moderation part, and then only it will allow the user to sort of like store the image, like keep the image on the channel. So that's it.
Mm-hmm.
So if you can see here, like there's a event subscription here as well. Then it would okay, they have the use case here. So I think we could have checked this first, this part, the use case part.
Yeah.
Anyways, so that's getting uploaded now in the channel, and Okay, so file removed due to displaying explicit or suggestive adult content. All right, so that image of yoga post got deleted in that channel directly. Okay, let's see the next image they're going to upload. So this is a very nice GIF note to show the use case. I like those sort of
Yes.
things in this readmes. Let's see what's the response coming. Okay, it wasn't deleted. So yeah, that's cool. Yeah, so this use case is, I think, very pretty straightforward, and it looks straightforward as well in the implementation level, because it just needed like event trigger, like okay, the Slack API would like trigger event, and I think you can listen like a subscription, and it would sort of listen to that like we can return to that subscription from the Lambda. So basically you can create like a, okay, someone puts a message to this, just post that message to this API
Yeah.
endpoint. So that's something
Exactly.
like that. So it's a very pretty, like, I mean, like, just trigger that.
Mm-hmm.
Something happens to that channel. So yeah, and I think we need this event subscription to call it back. I mean, like, to return a response back to the Slack channel, we need that subscription there. Yeah. Okay. So yeah, I think I'm not sure if we have anything much in detail to discuss in this architecture, but if we go through again slowly, so we can see, yeah. So according to this use case, we would need the API gateway because we need to provide that endpoint. Yeah. So that's perfectly fine there. And yeah, so Lambda, as we mentioned in our previous scenario, so if we can have another queue here, maybe. So let's see
Correct.
if that channel gets like hundreds of images at once, then this would be sort of exhausted here, right?
Mm-hmm.
Like the Lambda would be like in trouble, and even the MSN recognition would like get many requests per second, and sort of billing might go higher.
Mm-hmm.
So yeah, I think, yeah, what I feel is that's more like the sort of the disadvantage we can directly show. I mean, like, to improve this architecture, nothing much to add to that. So again, without a Lambda function, if we just imagine, if we have to, like, if you want to have like EC2 up and running, always listening to the API request, it would be very costly. So this is another perfect scenario, like AWS has suggested to use the Lambda function. So I think this pretty aligns with their functionality and like what the use case is to them. Yeah, Damien, anything else to add on this architecture, just before we like maybe go another full round and like so discuss the pros and cons once again
Correct.
with all the
Yes.
architectures.
So this is pretty straightforward. I mean, this is I wouldn't really call this a reference architecture, but this is sort of like this is sort of the standard when you build chatbots, I think, on Slack, because this is also what I did. I used a serverless function for that as well. I think this is pretty straightforward, and this is definitely something that would work out, especially if someone is looking to create a chatbot.
Yeah. All right. Okay. So shall we go around with the three architectures which we discussed, and maybe like do a quick pros and cons, and then go to a roundup session. So
Correct.
we
Yes.
discussed these three architectures. So I think we started with the first one here, image handler. So that was a pretty simple, like a dynamic image generation solution, image manipulation. So it will create a different resolution and serve it back to the CloudFront distribution. So that was that use case. So yeah. So and they had additional added. I think they're like the three architectures we discussed had MSN recognition on all of them.
Correct.
So
Yes.
there's something there.
This seems
So
like a
something to note.
marketing stunt for Amazon recognition.
Yeah. So yeah, you guys don't need to implement MSN recognition in any of these. You can just keep them out if it's not the use case. You can just use the normal flow
Correct.
without recognition. So yeah. So this one is pretty straightforward, and it uses CloudFront as a cache layer to cache the processed images. So let's say the thumbnail file or like different versions of the same image. And yeah, so Damien, if you can give like a quick pros here, so we can on this architecture.
Pros, of course, it would be that. Let's see, pros. Well,
For me, I layer like the cache layer, so just jumping in there, like the caching part, and because images are very expensive. I mean, like if you keep on doing the same thing. Let's say if you want to dynamically generate the image every time someone loads the page, it's super expensive to do that. And if you have cached it in an edge location, it's much faster and sort of like cost efficient even. So that's one advantage. I mean, across the three architectures, we discussed this as that capability.
Correct, that's true. And also, the default pros and cons of AWS Lambda also come into play here. So it's very highly scalable, it's very cost efficient, and all of that stuff coming here as well. I also like the fact that they've used Secrets Manager, but I have never heard of that use case regarding URL secrets. Maybe it's some sort of AWS implementation. I also like the fact that they're using API Gateway here. So it's basically you need to use API Gateway since this is basically publicly exposed. So let's talk a bit about the cons here. So I don't feel that since this is a dynamic image processing sort of scenario, I don't think that CloudFront will do a lot here. Especially if you consider that maybe these are like different versions of images that have been requested. If it's the same image that is being requested, then probably yes, CloudFront will have a big effect on it. But normally CloudFront is not a really good tool to actually go into and directly access a Lambda and do some processing and then return it and cache it back in CloudFront. So normally the architectures that I have seen, CloudFront sits directly in front of an S3 bucket, not in front of a Lambda. So I'm not really sure what sort of scenario exactly that this would benefit from, but it would definitely work, I think, yeah, if they need to do
I
some
think
sort of caching.
I think the CloudFront, I think it's not like a what do you call, like a entry point for the system. It's just, I think the delivery part they have just, I just try to read it here. I think they are just trying to like deliver the part, like delivery of the image only. Yeah, so that's I think good points we discuss in this architecture. So there are like many pros like we can keep on talking about as well. But I think we'll just quickly jump into the second arc. Yeah.
Let me just jump into one more pro here. According to this, basically, so there are two ways to do this. One is that you can store different versions of images in S3, and the second is that as and when that version gets cached, the cache expires on that version, you can ask a Lambda to process and get back a version to CloudFront. So what
Exactly.
would happen here is that your S3 costs would go down in this architecture. Your S3 costs would be greatly reduced. But on the other hand, whenever the cache is invalidated on CloudFront, it would need to go and it would need to consume a Lambda function here. So your Lambda costs on that side would increase. On the flip side of it, what I have normally seen is you have sort of like a Lambda function or maybe some sort of server that creates these different versions and stores it in S3, and that is in turn queried by CloudFront. So in that case, your S3 cost would go up. So the pro I would see here, if I understand the scenario properly, is that your Amazon S3 costs will reduce by quite a lot. Because
Yes. Yeah.
you will be storing only the original image and not the different versions of the image.
Exactly. Yeah. So that's one side of it. Other like the other implementation would be like storing multiple versions of the same image and just keep it as
Correct.
it is. Like there's no dynamicness, so there will be like fixed resolution.
Correct.
I think the sample project I mentioned, so it just creates three different versions, like in large and small only. So there's no dynamic nature there. So for that use case, this might not be the version. Yeah.
Correct. Yes.
Okay. So let's go into the second one. I think it's the image recognition process. Not this one. Sorry. Oh yeah. This is the good one. I mean, like the complex one, which we discussed. Yeah. From the pro side, I'll just jump in again. So I think using of AWS Amplify on the front end and sort of like for like a simple application, this might be very useful. Like having everything together, like Cognitor, Amplify, and S3 sort of bind it together, and you can do something like, let's say, S3 bucket, you can limit, okay, this owner would have only access to this folder, like you can lock it by the user ID sort of thing with Amplify. So that user would only access that folder, like public read won't be there, public write won't be there. So that sort of a limitation you can add here. And using GraphQL, obviously, like the currently ongoing like sort of state of that. And there's a proper like a flow maintained with step function. So we saw in there previous what do you call flow chart here in their description, they had like parallelly running two different functions, Lambda functions together in parallel and sort of having that hierarchical manner as well. So this has that sort of very good advantages, and like I think they have used a lot of AWS best practices in this architecture before I think putting it out. Yeah, anything to add, Damien?
No. Yeah, I agree
Yeah, I
with all
think
of
yeah,
that.
yeah,
And my main concerns here are on the cons. So
yeah,
on
yeah.
the
So we can
industry side,
discuss
yeah.
that. Yeah.
So on the
Okay.
industry side,
So
so basically, yeah, basically using queues and using reserved concurrency and basically doing that
I see.
stuff there.
Yeah.
Yeah.
All right. So yeah. So the third architecture, we'll just go into the pros here. So I think this was the most like the simple and
Mm-hmm.
straightforward architecture which we saw in this three architectures regarding image processing. This was very like pretty straightforward, and it's using Slack to like do integration and do image moderation. And it again uses MSN recognition. And in this case, they need MSN recognition. Otherwise, it would be like the end user, like sorry, the developer would have to create their own recognition API and be like time consuming. Yeah. So in this architecture, it's very straightforward. I think uh, again the structure and the flow is very like straightforward. The API gateway would trigger Lambda, then Lambda would trigger the recognition endpoint. Then again, you will get the response back, and you will return the response back to the Slack. Yeah, so I think it's very simple to get on, like get hands on if you want to create a Slack moderation sort of thing to your organization. So I think that advantage is always there, and a proper use case of Lambda, like very cost effective. It will only use like only trigger if it's needed. If not, it won't trigger that Lambda function. Yeah, that would be my thoughts on that. Anything there, Damien, to add on the pros
No,
side here? Okay.
I agree with
So
basically
we'll,
everything you said there.
I think, yeah, the last two architectures, I mean, after we discuss the first one, the other two are very similar in terms of
Correct. Yes.
pros. Okay. So let's get into cons. Um, yeah, this architecture, I think you can go first and give a perspective here.
So the cons here would, I think, be that your AWS Lambda costs would probably increase here, because whenever your CloudFront cache expires, you would have a bunch of AWS Lambda triggers coming in saying, okay, we need to get back and we need to recache all of this stuff here. Um, that would be, I think, a con. And what you would see is that at certain times of the day, you would see a spike in traffic to your AWS Lambda. And if your Lambda is doing anything else, like if it's been used by any other sort of services, that could be sort of a limit there, but that is very hypothetical. Other than that, I don't really see a lot of cons. This would actually, again, what I would like to stress is the pro here, which is that your S3 bucket, your storage cost would actually go down by quite a lot. So that is one thing that I
Yes.
really love about this architecture here. Yeah.
Yeah, and one of the like the cons, I mean, I think one day you mentioned that scenario where let's say you kept on invalidating the cache. So scenarios like that could inversely affect this architecture. So that's the downside of it.
Correct.
I
Yeah.
just have that. Yeah.
So
Other than that, it's
yeah, so let's take a scenario where something went wrong in sort
the
of
front end maybe
in
just
something went
yeah,
wrong in the front end, some sort of image got corrupted or something happened in the cache. You invalidate the cache. As soon as you invalidate the cache, your Lambda will be flooded with requests to regenerate all of those versions so that they can be stored back in the cache again. So that would be pretty bad. That would be a very bad situation, but that has happened quite a lot, and a lot of us we do tend to do it a lot. I think
yeah
Chamath, you have
we
also invalidated the cache a
yeah
lot.
yeah we if we just like quickly, okay, the first thing we do is invalidate the cache. We always think that's the issue.
Yeah.
So yeah, that's a negative part of that. Okay, so the third one, the chatbot scenario. So yeah, I think you are the best to give the, sorry, not the chatbot scenario, I mean our image processing backend part. So this is the
Yes.
detection, and yeah, so let's
So
give.
the biggest con I see here is, as I said before, it's with the scaling of your lambdas. So you're depending on a trigger from S3. So say you have a lot of photos being uploaded to S3. You would basically have a huge amount of lambdas being triggered as well from S3 as well. So that
Yeah,
would go on to start your workflow. and that would just dispatch all of these other step functions as well. So instead of that, what I would basically do is I would have a layer in front of the S3 bucket, which actually pumps data into S3, validates that it's stored properly, and then uses that metadata to trigger start workflow using an SQS queue. So what you can do is you can have an SQS queue before start workflow, and you can set a reserved concurrency for the Lambda, so that the Lambda won't scale up more than what you have set there. So that is very important, and that's sort of you really need that to happen there. So once it does that, then it can go and it can decide, okay, now I need to extract this image is completely fine. We have this record in S3. We need to go and extract metadata. We need to do object scene detection, generate the thumbnail, and we need to persist the metadata. So it can decide, okay, what other functions we need to start, and then through that it can actually go and dump it into other SQS queues, which in turn are listened by all of these other metadata, because basically none of these depend on each other, right? Extracting metadata, object scene detection, generating thumbnail. I think the main two things that don't depend on each other are object scene detection and generating thumbnail.
Yeah.
So I mean, those two can, even if object scene detection runs 2 hours after 2 hours after the entire thing happens, it's completely fine.
Yes. Yeah, just one of the main con I saw here is like this direct connection to MS and DynamoDB. I felt it's not the best practice here, because if we are going to a sort of a structured GraphQL API, we need to go with that flow. That's my understanding, because if something changes on that GraphQL schema, it like this Lambda function won't know what the metadata name or something like that. Simple, like simply basically changing a field name.
Yeah, so
that's one of the cons.
Something that's weird to me is that GraphQL is directly connecting to Amazon DynamoDB as well. So usually
it goes to the resolver, and I hope this is like resolving that and going into DynamoDB.
Yeah. I'm not sure what resolver is here, but
so one of the like AppSync has many inputs. Like you can put like API gateway, HTTP request. Then you can have DynamoDB. So yeah, AppSync is that sort of managed GraphQL service by Amazon. So that's why they have like added. Yeah. So I think one of the outgoing would be step function. So that's why it's going through a resolver, and then I think with the cons side, that was it from my end, because it had many good sides. I mean, these architects, because we even saw their proper demonstration and sort of the real world scenario application here. So, and one of the key things to like note here is mainly this, what do you call there's no caching layer. So as we saw, there was a caching layer, but this one doesn't have that caching layer. I think the different use case might be there, so it might directly serve from the S3 bucket. So that's why it happened. And so I think it's all good here for now. So let's ask the architecture and discuss its cons as well before we wrap it up for today. Okay then. So this is the simplest one again. when I keep seeing this architecture, I just like, okay, this is too simple. I just feel that get that mindset directly. I don't know why. Any cons here? I think you mentioned the previous similar scenario, like let's say if the chat dumps, let's say thousands of people try to chat in the same channel, upload images, this might get like pumped with the API request, and then the Lambda might get stuck. So ideally, we need to have a middleman and sort of queue them before sending into the.
Because again, here this is not dependent on. This is like anyway. Once you upload the image, people will see it, right? It's going to be deleted maybe a second or two later, so it doesn't matter if it's deleted maybe on 5 or 6 seconds later. It would always be better to have a queue with reserved concurrency on your Lambda, so that it actually, you can manage the costs of actually running that Lambda as well.
Yeah, that's true. All right. Yeah, I think that's our cons section, I feel. With these three activities, I think we covered a lot on the pros and cons, and sort of like three different, like completely different three use cases. I think this Lambda reference architectures by AWS is really good, and like sort of some are very in detail and some like very simple architecture. So it has a whole mix of that.
It's
Okay,
also
so
good.
let's
Very,
go.
it's also a very good starting point for someone who wants to like get into this stuff.
Yes,
Um,
yeah,
like say you want to build sort of a chatbot, you want to build some sort of image recognition software. This is a really good starting point. I mean, it might cost a lot. I mean, it's on
yeah,
AWS.
but yeah, I think getting hands-on would be much faster with
Exactly.
this.
Yes.
Yeah, yeah,
So personally, what I would recommend is get in the free tier for AWS and then just trying all of these out.
yeah, exactly.
Exactly.
All right.
So that is very interesting, Chama. Thank you very much. And I think we can end on that note today. So
Yes.
basically, we talked all about different architectures that you can come up with for serverless. We went through web, mobile, as well as different sort of image recognition and image processing architectures that
Awesome.
we could actually do. So
Yeah.
next up, we have Netflix load shedding, and that's the next topic that we have planned to talk about and to have a sort of short discussion about. And so I guess we'll see you all on the next episode.
See you guys.
All right, cheers. Bye.